Okay, today's lesson, we're going to be learning how to graph inequalities on a coordinate plane. Now, we've talked about inequalities before. I think you've had these, so I'm going to go give you a little background information. So if you've got 2x plus 5 is greater than 7, how would you solve that? No, not necessarily. We need to solve for x. It may not be, it may be a fraction. What if I had 2x plus 5 is equal to 7? Okay, guys, it works the same way. I'm not understanding exactly why we're not making the connection that you solve for x the same way. As soon as I put that equals in there, you knew exactly what to do. You said subtract 5. We're going to subtract 5 here. So that gives us 2x is greater than what? 2. Now how will I get x by itself? Divide by 2. So x is greater than 1. Now on the number line, y'all have done the number line before, correct? Okay. Would this be an open or closed circle? Open. Why? When is it closed?
It has to be.
How do you know it has to be that? It has to have an equal under it. So this is saying open and x is greater than 1. Where are all the numbers greater than 1 on the number line? To the right or to the left? To the right. Okay, you remember graphing those inequalities on the number line. Okay, so now we're going to graph inequalities on a coordinate plane. So it's going to look something very similar to this. Now, if I was graphing that, now that's not an inequality, that is a what? Just an equation, because it has an equals. Now, where would I put my very first point? At -2. That is your y-intercept, correct? Now, how would I get my other points? Up 3 over 1. You use your slope. Okay, so first of all, I want to use my y-intercept and graph that point, and then I get all my other points from my slope, up 3 over 1, up 3 over 1. Now, then I'm going to, it's hard for me to do right here, but I would connect that, and I'm going to give y'all some rulers here in a minute. Okay? So now what we're going to do is we're going to graph inequalities. Okay, so write this one down. We're going to sketch this. And this is going to work the same exact way with a couple of minor exceptions. So, where am I going to put my first dot? We're just going to sketch this. -5 on which axis? On the y. Just sketch it. So I'm going to go 1, 2, 3, 4, 5. Okay. Now how will I get my other points? Up 2 over 1. You get it from your slope. So I'm going to go up 2 over 1, up 2 over 1. I want you to give me at least 2 to 3 points depending on the size of the graph. Now, we're not going to do anything just yet. Okay? If I have greater than or less than, on the number line, you told me it was what kind of circle? Open or closed? Open. Guys, when you're graphing it like this on a coordinate plane, it's going to be a dashed, or what I would call an open line. Okay? These are going to be dashed. Open circle in the number line, dashed line on a coordinate plane. Open line, so to speak, okay? Now, what if I had equal to's? What do you think my line would be? It would be solid. Okay? Now, let me help you explain. Let me explain something, help you understand. When you've got an inequality, you don't have one answer that makes that true. You have a whole bunch of answers that make that true. Okay? We're going to go back 2x plus 5 greater than 7. How did we solve this? Subtract the 5. 2x is greater than 2. X is greater than 1. Okay? So anything greater than 1 would make this statement true. Let's test that. Give me a number greater than 1. 2. 2 times 2 plus 5 is 9 greater than 7. Give me another number greater than 1. 10. 2 times 10 plus 5, is that greater than 7? Let's try 1. 2 times 1 plus 5 is 7 greater than 7. No, it didn't say it could be equal to. So do you understand that I've got an infinite number of possible solutions that would make this true? That's why this is an inequality. Okay? Any number greater than 1. Well, let's check a number less than 1. Let's just see. Pick a number less than 1. Negative 2. Okay? What's 2 times negative 2? Plus 5 is 1 greater than 7. Not true. Let's try 0. 2 times 0 plus 5 is 5 greater than 7. So when you have an equation, x can be one and only one solution. So if I made this an equals, okay, let's look up here for just a minute. If I made this an equals, the only thing that would make this statement true is what number? 1. That's the only number. But when I have an inequality, I have an infinite amount of possible solutions. Now let's see how we show that on our coordinate plane. So y is greater than all this. I want you to put your, and I'm going to put it, I'm going to do this. I want you to put your pencil on that line somewhere. Now, y either goes up or down, correct? The y-axis, up or down. Where are all the numbers greater than this point? Up or down? Up. So this is the side of the line that you will shade. And you shade it to show where all your solutions lie. You can pick any number, any value of x and y in this shaded region, and it will make this true. Okay, so let's try that. Let's pick 0, 0 as something that's pretty easy. Is 0, 0 in the yellow region? Okay, so I have 0, 0. So that means my y is 0, correct? And my x is 0. So 0 is greater than 2 times 0 minus 5. Is 0 greater than negative 5? Yes. Is that true? Okay. Let's try 1, 1. Does that look like it's in the shaded region? Okay. So my y is 1. My x is, oops, crazy. My x is 1. 1 is greater than 2 minus 5. What's 2 minus 5? Is 1 greater than negative 3? Yes. Well, let's check one that's outside of this. So I know it has to be below 5, so I'm going to go with negative 6. Let me just go with 6, negative 6. I'm going to go with 6, negative 6. Because that looks like it's outside. So negative 6 is my y, correct? Greater than 2 times 6 minus 5. Negative 6 greater than, what's 2 times 6?
12.
What's 12 minus 5? 7. Is negative 6 greater than 7? No. So, let me go back to the basics. When you are graphing an inequality on a coordinate plane, how you show that it includes the points on the line or doesn't include the points on the line is you do a dashed or solid line. Then you're going to put your pencil somewhere along the line. If it's greater, you go above that line. If it's less than, you go below. Okay? Let's do one more example, and then I'm going to give you pages. All right? Okay, we're just going to sketch this. I'm fixing to give you worksheets that have actual grids on them, but right now we're just going to sketch it. Okay, where will I put my first point to graph this? Just like you would a line. Negative 2. Now to get my second points, up 3 over 1. 1, 2, 3 over 1. Okay? I'm just going to do 2 points right now. Now the next thing that is very, very, very important is whether it's a dashed line or solid line. Solid. And how do you know? It's equal to. That means that any point on that line will make this true. So I'm going to draw a solid line best I can with my little tablet. Okay. Okay. Now, I'm going to put my pencil somewhere on the line. Now, what is my inequality? Greater than or less than? Less than. So, where would I go? Above this line or below this line? Below. And I want you to kind of shade as much as you can, to show along that side. All right, where are your questions?
How do you figure out where to shade?
Okay, you put your pencil on the line. Look at the inequality. What is my inequality? Greater than or less than? Less than. So I have to go below that line. Okay, good question. Another one, please. Okay.